Let's review for Chapter 9. We're on page 545. This is the practice test for Chapter 9. We'll do 125, but we're going to skip 13 and 22. So beginning with number 1, we're told to write each expression using exponents. So they have negative 2 being multiplied by itself 3 times. So to do that, to write as an exponent, you just note this is multiplied by itself 3 times. So you just keep negative 2 just as it is. But now we put an exponent of 3. Because something is multiplied by itself 3 times, that means it's an exponent of 3. So this is the same as negative 2 cubed. Number 2 is similar. We have 3 times b times b times b times b. So there's only one 3, so we'll just write 3. But there are 5 b's. 1, 2, 3, 4, 5. So that's the same as b to the 5th power. Number 3. They tell us for 3 and 4 that c is equal to 2 and d is equal to negative 3. So we use this information for both number 3 and 4. 3, we're supposed to evaluate c cubed plus 5. So I plug 2 in for c. 2 cubed, you can plug this in your calculator if needed. 2 cubed is 8, and 8 plus 5 is 13. Number 4, still using the same facts about c and d. They ask us to find c minus 4d squared. So I plug in 2 for c, and I plug in negative 3 for d. They've got to remember, if you plug this in your calculator, you have to put the negative number in parentheses, or the calculator is going to misunderstand what you're trying to do. Negative 3 squared means negative 3 times negative 3, and a negative times a negative equals a positive. So negative 3 squared is positive 9. Squaring things always makes it turn positive. Now I have to follow the order of operations. Multiplication comes before addition or subtraction. So I say 4 times 9 is 36, and 2 minus 36 is negative 34. Okay, number 5. It says, when the United States had 48 states, the stars in the flag were in a 6x8 rectangular arrangement. So 48 states, they had it 6 rows and 8 columns, or maybe it was 6 columns and 8 rows, regardless. Which of the following rectangular arrangements of the 48 stars would be impossible? So our options are 2 times 24, 4 times 12, so that's actually C right there, B is here, 3 times 16, or D, 5 times 10. Well, if you think about it, when you make an arrangement of something, if you have 6 rows and 8 columns, all you have to do to figure out the total number you have is multiply. Yes, we often say this 6 by 8, but it also means 6 times 8, which is 48. 2 times 24 is also 48, so that would work fine. 4 times 12 equals 48, so that would work fine. 3 times 16 is 48, that would work fine. But 5 times 10 is 50. And at this point, the U.S. did not have 50 states. So this one would not work. So D is our answer. So for number 6 and 7, we're told to factor each monomial. So to factor the constants, well, if it's a negative, first thing we need to do is factor out negative 1. So I'm going to try to work with just the constant part over here first. So we have negative 1 times 15. But then we need to do the prime factoring of 15. So you can use a factor tree if you want to. 15 is 3 times 5. And both of those are prime. So we'll use negative 1 because of the negative sign, 3 and 5. So we get negative 1 times 3 times 5. And then the variables, I think, are pretty straightforward because you just put as many of them as there are based on the exponent. So in other words, this is r to the first, so just put 1r. This is s to the first, so just put 1s. Now on 7, we don't have to worry about a negative sign, so we can just go straight into a factor tree. 26 is even, 2 goes into it, and 2 times 13 is 26. So 2 and 13 are both prime, so we're actually finished factoring that one. We'll just write 2 times 13. And then there are 3 b's, so I do b times b times b. There's a c squared, so that means there's 2 c's, so I do c times c. And there's 1d, so I just write 1d. d to the first means write 1d. Okay, number 8. Which of the following expressions represents the area of the square? So I'm just going to work this one out, and then we'll talk about which answer it is. We have a square, and they tell us one side is equal to 3ab. So remember, the area of area of a square is side squared. So they told us the side is equal to 3ab. So we can write this as 3ab squared, because I'm just pulling this 3ab and putting it in for the side. So now, as we talked about with exponents, you have to apply the squared to everything inside. So 3 squared is 9. A squared, that's a to the first, 1 times 2 is 2. That's b to the first squared, 1 times 2 is 2 again. So we get 9a squared b squared, which is letter J in the book. Number 9 says find each product or quotient. This is the same for 9 through 12. So 9, we have 9 squared times 9 to the 6th. So you have to remember that when we're multiplying the same bases, the trick is to simply add the two exponents together. 2 plus 6 is 8. Number 10, we have k times k to the 5th. So remember, when there's no variable written, there's an when there's no exponent written, there's an understood exponent of 1. And when we're multiplying two bases, we add the exponents together. 1 plus 5 is 6. Okay, 11. We're dividing now, so negative 2 to the 5th divided by negative 2 squared. So when you're multiplying, you add the exponents. When you're dividing, you subtract them. So we keep the base the same. We keep it as negative 2. Just like we kept it as 9, we kept it as k. But instead of adding, like we did up here when we multiplied, we subtract because we're dividing. 5 minus 2 is 3. And then 12, we have 11y cubed times negative 3y to the 7th. So please remember, keep the coefficients as separate things. We don't use exponent rules on coefficients. We're multiplying, so we just multiply. 11 times negative 3 is negative 33. Y times y, we add the exponents together. 3 plus 7 is 10. So we get negative 33 y to the 10th. Okay, we're skipping 13, so let's jump to number 14. 14 says write each expression using a positive exponent. That's true for both 14 and 15. So 14, we have 10 to the negative 10. So what you have to remember is a negative exponent means that you are dividing, which also means that you can rewrite this as a positive exponent by changing where it is in the fraction. What fraction, you say? Well, even whole numbers can be written as fractions. We just put them over 1. So while this is 10 to the negative 10th when it's on top of the fraction, it's 10 to the positive 10th on the bottom of the fraction. We'll do something similar with number 15. It starts as m to the negative 5, and it's understood to be over 1. It's a negative 5 exponent when it's on the top of the fraction. It's a positive 5 exponent when it's on the bottom of the fraction. Okay, 16. It says write 1 over 121 as an expression using a negative exponent other than negative 1. So first I want to explain why they say other than negative 1. You could say, well, this is 121 to the first power, and since it's a positive exponent on the bottom, I could bring it on top and make it a negative exponent. Now this is mathematically true that these are equal, but they're saying find a way to do it where you're not going to have an exponent of negative 1. So what you have to think is, what number raised to a power equals 121? Now if you don't know, you can guess and check in your calculator, but it turns out 121 is equal to 11 squared. Now once we've rewritten it as this, if it's 11 to the positive 2 in the bottom of the fraction, it's 11 to the negative 2 in the top of the fraction. Okay, we're in the home stretch. Jump to number 17, talking about scientific notation. They want us to write 3.4 times 10 to the negative 5th in standard form. So remember, when it's a negative exponent, that means it's a small number. So we need to move the decimal point to the left 5 times. So 1, 2, 3, 4, 5. So the decimal goes there. Have to put zeros in all the blanks. 0, 0, 0, 0. So I have 4 zeros, the 3, and the 4. So 3.4 times 10 to the negative 5th is the same as 0.0000, 4 zeros, 3, 4. Same process on 18, only this time we've got a bigger number. So 7.29 times 10 cubed. So this is a positive exponent. That means this is a bigger number. So instead of moving the decimal point to the left, like we did here, move it to the right. 1, 2, 3 times. Now I have a blank here, so we have to put an extra 0, making this 7,290. '19, we're going in the opposite direction for 19 and 20. They give us a standard form number and tell us that we should write it in scientific notation. So let's do that. The decimal at the moment is right here. We need to move it so there's exactly one non-zero number in front of it. So we move it to the left 1, 2, 3, 4 times. So I'll do 5.03 times 10, and since I moved it to the left 4 times, I'll raise it to the positive 4th power. And it's positive 4 because we moved it to the left. It's also positive 4 because positive exponents mean the original was a bigger number than 1. 20, we have 0.008. We want to move the decimal to the right until we have exactly one non-zero number in front of it. Move to the right, 1, 2, 3. So this is just going to be 8, or you could write 8.0 if you want. Either way is fine. Times 10. And we moved it to the right 3 units, so it's negative 3. Because it's going to be a negative exponent anytime you have a small number, a number smaller than 1, which this certainly is. Okay, 21 is about volcanoes. There's a table in your book that shows the greatest amounts of lava in cubic meters per second that erupted from 6 volcanoes in the last century. Now we're just looking at 21 on this because we're skipping 22. But it says, order the volcano eruption rates from greatest to least eruption rate. So I'll just list them in the order they are on the table. Actually, I think I'll just show the table and we'll list them from there. I think that'll be easier. Give me just a second to adjust. Okay, so here's the table. And they basically wants to list the actual names of the volcanoes in order. So they say from greatest to least. So we're looking for the greatest eruption first. When you're trying to figure out scientific notation from least to greatest, or greatest to least, put them in order, in other words, you want to look at the exponents first. So right away, I see that there's one exponent that's a 5. So that means, I'm just going to say Bez. Sorry for being lazy, but I'll write the answer for 21 right here. Bez will be the greatest because it's to the 5th power. And now we see 1, 2, 3, 4 of them to the 4th power. When they have the same exponent, we need to look at the number in front. So I see a 4, a 2, a 3, and a 2. So the 4 is the biggest, so Santa Maria goes next. The 3 times 10 to the 4th is the next biggest, so it's a gung. Forgive me if I pronounce these names wrong. But we have 2 that, at least on this table, are identical, and that's Hecla and Mount St. Helens. So it wouldn't matter which order you put those in. You can even put them on the same line if you wanted to. But if you're listing them out, horizontally, I would take these in either order, because as far as the table is concerned, those 2 are equal. So that leaves us down to 2 more, and these are both 10 to the 3rd. So the bigger one is the one that has the bigger number in front. So Hecla, wait, I wrote the wrong name earlier. Shoot. Hecla happened twice. Never mind. Okay. That's what happened. See, Hecla shows twice. So this Hecla is up here. This Hecla is smaller, so it's down here. And the volcano with the smallest amount of eruption was the 2 times 10 to the 3rd, which I'm going to abbreviate like that. So make sure you do pay attention to the directions. It says greatest to least. So we've got to start with the biggest and go to the smallest. Okay, last 3. 23 through 25, we were just told to simplify. So this is where we're using exponents raised to exponents. When it's an exponent raised to an exponent, you multiply the exponents together. So 2 times 6 is 12. So this is equal to 4 to the 12th. 24 is p to the 7th cubed. So we do 7 times 3, which is 21. Okay, 25 will take us a little bit longer. It's got a little bit more going on. We have 3c to the 4th, d to the 6th, all being raised to the 4th power. So remember, when you have more than one piece, letter, number, whatever it is, inside, that exponent needs to apply to all of them. So this is 3 to the 1st power. I do 1 times 4 and get 3 to the 4th. 4 times 4 and get 16. 6 times 4 is 24. So this is correct, but since you have a calculator, we can go ahead and say what 3 to the 4th is equal to. And 3 to the 4th power is equal to 81. So we get 81, c to the 16th, d to the 24th.